What do you call people who are in favor of tractors? Protractor. You get it? What we've been using since 6th grade to measure angles. And that leads us to today's lesson. We will be talking about angles and angle postulates. But first of all, to review, what is an angle? An angle is the amount of turn or rotation about a point called the vertex of the angle. So what is the vertex? The vertex, as you can see, is where the two rays or lines or segments meet to create the angle. When we are naming angles, we can use 3 points. So as long as the vertex is in the middle, you might be tempted to call this angle angle ABC. But the turn is about angle A, so A has to be in the middle of the angle name. So we have this little left pointing arrow, that's the symbol for angle, and then we have 3 letters, B, A, C, or we can also call this angle CAB. There's also another way to name an angle, and that's just with the vertex and no other letters. You can only do that when there are no adjacent angles. So in this case, since this is the only angle on the screen, I can shorten it and just call it angle A. Now, when we're talking about angle measures, we're talking about the number of degrees in the angle or the size of the angle. So when we want to talk about those things, we just put a little m in front of the angle name. So measure of angle BAC, measure of angle CAB, and measure of angle A all give the number of degrees for this angle. Now, in your book is the angle addition postulate. And what that just says is that if you add 2 angles together that are adjacent, so we'll say this angle which has alpha, and you add that to another angle which we will say theta, right here. Anyone in the Mu Alpha Theta Club, by the way, the math club? So when I add alpha to theta, I should get phi. This last symbol here, which I will mark with the green. So the red plus the purple should equal the green, which makes sense. Now let's go ahead and apply this to a few examples. It says here L is in the interior of angle JKM. And the measure of angle JKL is 42, and the measure of angle JKM is 70. They want you to find the measure of angle LKM. So if you have the notes that I handed out, or if you're taking your own notes, really there was no picture associated with this problem. We do know that K here is going to be in the vertex. See the K right here. So I know that K has to go down here. Okay. And then I know that JKM make the big angle and L is inside. So using that information, I named the angle, the points on the angle like this. So I drew a set of angles, 2 adjacent angles, and then I named the points. So the first thing I know is that this 40 degrees here, and I'll go back to my pointer, this 40 degrees here is for this interior angle from, I should say 42. And then the 70 here is for the larger angle because it's JKM. So I write an equation, angle JKM equals JKL plus LKM, and I substitute in 70 and 42. So 70 equals 40 plus the measure of angle LKM. And I apologize that my L looks like an angle symbol. Then the next step is to subtract 42 from both sides because we're trying to isolate our unknown here on the right. And I get 28 equals the measure of angle LKM. I would like to see you writing these as equations. I know some of you will say, oh, I can do 70 minus 42 and get the right answer. And yes, you can until we get to the more complicated problems. So really go ahead and get in the practice of writing an equation using the angle addition postulate. So angle bisectors are something else we also studied. Bi means 2, and sector is like cutting in pieces. So we cut into 2 sectors. Angle bisectors cut the angle into 2 equal parts. So this angle is going to be congruent to this angle. Or you could say that either one of these angles is half of the large angle. AC is the ray, it is the angle bisector of DAB. So let's use this for an example. we have YOV is 155 degrees. OV bisects this angle, UOW. And we want to find out VOW and UOX. So for the first thing, I'm going to use the angle addition postulate using this large angle they gave me here. I know that YOV equals, the measure of that angle equals the measure of this angle, YOX, plus WOX, plus WOV. Now I'm going to substitute in the numbers, and I get 155 equals 40 plus 90, plus the measure of the angle VOW. But wait a second, 90 wasn't up there. How did I know that was 90? Well, you should remember from middle school that the square in the angle implies that that's a 90-degree angle. I combine my like terms, so I have 155 equals 130 plus the measure of angle VOW. Subtract 130 from both sides, and I find out that VOW is 25. But I'm not looking for VOW. So you're like, I did all this work for nothing. But actually I did. So I'm looking for VOU, which, by the way, remember that UV is a bisector. So VOW and UOV are the same, which means I can say measure of angle VOU, or UOV, equals 25 degrees. Then I want to find UOX, so I'm just going to say UOX. So that's up here, right, from this angle, and that angle. Substituting in the values I know, 25 plus 25 plus 90, and I get 140 degrees. For our last example, we're actually going to go back to segments for a second. And a lot of times we might ask you to put points in the proper position. We know that A, B, C, and D are collinear, but not necessarily in this order. B is the midpoint between C and D. A is the midpoint between B and D. Now we want to place the points on the line using this information. So B is the midpoint between C and D. And I know A is in the middle somewhere. So my endpoints at the very end are going to be C and D. And I know B is in the middle. A is in between B and D, so it's going to go right here. Now, I don't know that it's actually in this order. Another acceptable answer for this question is that one, where I put switch C and D and then place the points accordingly. Don't forget to write your reflection. You were told that segment AB is congruent to segment BC. Point B, is that always, sometimes, or never the midpoint? And defend your reasoning. You may use drawings to justify your conclusion. Good luck.